So in this second part, you're going to see a lot of slides, but it's not meant that you have to learn them all. It is just to give you an idea about the setting, the setup, so to say, of the environment related to the philosophy behind that. And it is the part that is valid for the old JBC, for JBC4, and it is also transported into DIME. Okay, so it is just trying to explain to you what are the principles and then how it looks like in practice. So I mentioned already the one thing approach, which is the idea of having these kind of models, more or less like the ones that you saw, as the meeting point for the design of the system, for the system design, really, between the different parts of, experts that are working in that, those who define things, those who check things, those who run things, those who build things, and all the auditing and so on. That's the kind of level of models that we are talking about. And we have basically an approach that is called extreme model driven design, XMDD, okay, uh, which is actually, we like equations, so you see that there are four components to those. So for this extreme model-driven design, which is the ones in order to have this service-oriented continuous engineering with one thing approach for the models, so it starts to be full of keywords, okay. I would like now to briefly explain to you what are the different components, the different ingredients of this XMDD, right? So the first is MDD, model-driven design, okay? Model-driven, probably you know it, but okay, it means basically that, well, you're not talking about the real things, which is the code in our case of the system, which is hardware and software together, but you're talking about models. Models are abstractions. Models are just things that are evidencing some aspects and maybe disregarding others, right? Like for instance, okay, this is a model of a car, the VW Käfer in Maggiolino, okay, but you recognize it. You would know what are the different elements or whatever. You see a steering wheel, you see these other things, but of course, very clearly, it is a model. It is not something that you can use, right? Well, model driven means that the models are the first class citizens. First class citizens means not just there for description, like a documentation, okay, but really, the thing on which you work, which means that system changes happen only at the model level. It is pretty much integralist. It is not touching the code here and tweaking a little bit there. No, 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 no. If you want to change something there, go to the model, change the model, and then generate again, okay? So the models are really the sole and central development artifact. That's why we didn't want you to start hacking code, okay? There is code in there, of course, but it is code in a certain philosophy and inside a certain architecture of the application that is a model, okay? So that's why it is important. The traditional model-driven, so to say, which is already very modern for software engineering, is actually that you have the models, but basically they are just a sort of a blueprint and guideline, and then you look at the models, very nice, and then you go somewhere else and write your code manually. There are some generation possibilities, but they are very, very partial, okay? Because the models don't have enough information, basically, okay? So, and because actually you're going every time, so to say, to create the code more or less from scratch, binding code from libraries. So this is nice because it means models are important and there is a way of dealing, of working with models in a sophisticated way, okay? But it is not enough. You need service orientation. Service orientation basically is, let's say, a concept of hierarchy, like components, and components that are part of other bigger components, that are part of other bigger components, this kind of modularity and exchangeability, when it just goes on steroids, right? It just goes big. It just goes very intense, right? So the idea is actually that you're going to have some things that exist, like the web services that we talked before, okay? They exist. They are going to be wrapped into services of which you don't know anymore how they are made inside. You just know the description at the border, the description at the API or something like that, but higher level than the API. I call it the model of the caramella, okay? Because it is, there is the bonbon inside, and then there is the wrapping, okay? So we work in a world of caramelle, tortellini, or whatever kind of, mental thinking you want to have. So it is not spaghetti code. It is not lasagna, like, layered approach. It is a tortellini world that you have, okay? Just, I always make jokes about the fact that I'm Italian and everybody loves pasta, and everybody understands that, right? Even the Chinese have their own dim sum, so that works, okay? So the idea is actually that the services are these tortellini. They have an interface, which is the first thing that you see, and there is an inside, which is code at some point, or it is other such graphs, like the ones that you saw before, that you can open up and you find it. But at some point, you're going to hit on a database, on an API, or on some code. And if this code doesn't exist, well, you have to create it and sit down and hack it, okay? So you can integrate legacy systems, things that exist before. You can integrate components. This is components off the shelf, okay? Components that you can find, the libraries or whatever, like in C or whatever it is. You can integrate other services, like web services, which are a particular flavor of services, okay? Or you can implement yourself new things when you have defined what you want to have, which is the wrapping, okay, and the description of what should be inside, and then you fill it up, okay, and you put the real filling instead of just a placeholder. We are going to work with placeholder SIPs later, so you're going to see that, Okay, so if you have models, you are composing and modeling by means of services. Now, who is using this tool? Well, extreme programming was a way of doing software that basically involved the user. It would have been like, Frederick and me, maybe he the developer and me not knowing anything about developing, like for instance a nurse, okay? Sitting together with one keyboard and developing together, because I tell him what I need and he does it, so to say, and then we test it and so on. Extreme programming was actually involving the non-technical or the user, the customer, whoever it is, actually in the design from the very beginning as an integral part all along it. Not just, you tell me what you want, put it into a Word file, and then I'm going to read it, guess what you want, implement something, somebody else is going to test it, and then you have to check, so to say, whether what came out of this entire chain of stuff development that has happened without you has anything to do with what you really wanted, okay? So extreme programming has a problem. With programming and with code, it doesn't work because people that are not programmers don't understand the code. So what we want to have is extreme, which is good, which means the user, but model-driven, because they understand the models, okay? So XMDD has very short cycles, based on user feedback. Since then, they invented agile programming, so it's basically agile programming, okay? It has customers and application experts all at the same table because of the one thing. And basically, you start with the story of the story high level, like I showed you before, and it becomes more and more precise because every time that you have decided what you want to do, I want to do this, and then this, and this should happen, and that should happen, and in this case, we go back, and so on and so on. Then the second layer, after you have decided this, is how. How should this action happen? So you take it, open it up, and you explain again what should happen, another graph, so to say, like the ones that we saw, for this action. And then you go to another place, you open it up. How should it happen? So in this way, you have basically a continuous refinement until you come to these objects that are really the technical objects or that are actually the APIs on which you hit on legacy systems, right? And you can actually do this job very much with the users all the time, okay? Rapid prototyping and so on. And then the aspect orientation is basically separation of concerns. If you look at things like, error handling, security, governance, performance, privacy, or this kind of stuff, they are basically cross-layer concerns that concern the entire system. So you have to be able to define properties and to ensure these properties, so to say, on the entire system and to define them in a different way. There are things with views and product lines. There is wonderful software engineering that can be done here, but it is not relevant to today, so we just skip it, okay? So if you want to just summarize how extreme model-driven development is different from traditional component-based design, well, in component-based design, you have a lot of components, and they are code. You are integrating this code at the level of source code by writing more glue code, okay? And if you have models, they are just descriptions somewhere, like, you know, a clever documentation in a certain sense. Yeah? It could be a sort of a, you know, beefed up doxygen, and that would be enough. That's the model. That's what you define, so to say, as description. Now, if you look at the traditional model-based design, what people found out is actually that it was not enough to look at the code, because you spend, you know, it is too detailed, and there are too many tricks that actually you don't find out. If you want to make a test on this, try to take the code, so to say, that is defining, let's say, for instance, exponentiation by means of addition. Okay, exponentiation, you can transform it into many multiplications, and the multiplications are a series of addition. Okay, take somebody that doesn't know how to code and throw them basically the code that defines exponentiation by means of addition. But you don't tell them what it is, and they have to find it out from the code. Good luck, right? So it's much better to have a model that basically tells you, wait, I'm doing this by means of that, and this is done by means of that. Easy, right? So that's what we are trying to do. The people that do model-based design, they basically tried to take different kinds of models and to have different kinds of aspects in the one, in the other, and in the other. If you know about UML, the Unified Modeling Language, UML, is actually this kind of thing that has come out and has become a standard there. There is one problem: they cannot really generate a source code, and then people that use UML, actually, because the models are so difficult, so different, and so difficult to manage, they end up modifying things in the source code. And then there is the huge problem of reverse engineering, which is, okay, now that we have this modified source code, how do we represent these new modifications in the models? And the answer is you can't. In 99% of the cases, you can't. And in the 1% where you can, this is of no interest to anybody, because the interesting things, they are actually in the 99%. Okay, so it is a failure. So what we do something different. We basically say, no, we work only on the models. Okay, we have this kind of models that instead of having different concerns, different kinds of things, it is just everything in the one thing. Okay, and then this one is fully automatically code generated for the glue code. Okay, you're using the services, and there is only very few code that you have to generate in order to put it together. Okay, and that's easy compilable down. And anytime that you want to change something, don't touch the glue code. Back from the hands away. Okay, you don't touch that code. You go to the models, and please do that. If you start modifying your own code generated, you're going to get problems yourself, and then also with us. Okay,